Was thinking about me. When you feel nose, that means what was thinking about you. Well, yeah, lovely. Definitely was thinking about me. Publish link to the video.
There are many internships.
Any design?
No, if you just
Not
go and
understood.
search, there all
I
are
make most.
languages. Sometimes it's supposed to be done, but they never reply.
There are some specific people, but they won't reply. I made them.
Who and why?
And next semester, we want to send this a report to her and
Yeah, what would never
this
say
is
this
the
anything.
Yeah. What is this happening?
in your decision.
Okay.
10.
Your decision okay? What? What was the date? 6th April.
6 I submitted the post maybe 8 or tomorrow.
They mail you back with the decision date or not?
Did you get that?
Yeah.
We didn't.
They don't count working days. They just count 30 total days.
Mm.
I mailed on 11th and 11th of March and they decided.
Also, I have made a mistake in the cover letter, so they replied me that
Which cover letter? You filled both form? No, no.
no,
Just one single form,
yeah,
single
yeah.
page.
That page they gave me back and said me that we want to fill once more and please send it.
What mistake did you attach photo also?
I don't know.
You attached your passport photo on it or not?
After that,
What mistake did you do?
I don't know.
But you filled the same and
Yeah.
again sent mail the letter.
So when I will get the decision or tomorrow, I submit.
I've got the date on 10th I will get.
From which division did you
One only.
One. I submitted to one, but they sent to the
This Monday
Jacob
Mera
Hills.
Street.
My document sent to the Jacob Hills branch.
You could choose what number.
Jacob Hills is out of Florida.
Okay. That I don't know where they have sent. Let me see the decision. You got your RP?
He just submitted it.
Working on it.
I would float in January, but they don't call me back. They told me it's a training period.
For what?
Bharat. So I just work for 4 days.
How many?
10 12.
So it's good, I guess.
Yeah, it's good,
What's
but
the pay? What's the pay?
3 and
In hand. In
no.
hand. Alex, after taxes?
Yeah,
Before taxes or in hand?
before
This
tax.
is-
Yeah, before tax is 4.
These are the two terms. Before taxes or in hand. So it's nice, bro, if you are doing 40 or 50 hours.
But they only count 10 hours per day or 2 hours to cut because of it's a break hours.
Now 40 hours is enough to depend how the student. Rest of the day do both, no? You have cycle.
Cycle and but they didn't call me that I want to message you.
I want a cycle if you know someone who tell me.
You are also doing
I'm doing kebab, but I've turned my this W into bicycle mode, also get the bag. I think I should do sometime for 10 minutes, 15 minutes, whatever.
you work in art piece.
No.
Discover
Cozy corner. Brewers kebab.
how is it? It's good. What is good?
why is also Jacob is ground?
That's why I said.
This name, right?
Yeah.
So here
Because
you didn't cut this.
They also send me like this. See? But in this they have mentioned that you understand the problem.
But the date is here.
Nine.
Nine.
9/4/20.
That's it.
I'm just worried about how will I get that.
So the export take time, mail don't take time. Get in exact 30 days, and
Yeah.
get in 33, 4 days.
Because 2-3 days for the.
So just send it back in a
Yeah, but my friend told me that it's better to post. So I decided.
and time don't take. So just
Do you like Earth balls?
No.
Yeah. Yeah, idea. Network of isolated neutron. Yep. In theory, in stupid theory, if fault will be zero. Will it be zero? No, it will not be zero because there are line to ground capacitance. Capacitive current will form current at fault place. Will it be large? No. Actually, old time school tell you if this current is less than 15 amps, you can ignore it for 8 hours. Will you ignore it?
No.
Why? It's a distribution network. 3, 6, 10, 11, I don't know, 24 kilovolts. Why you're not ignoring this current? Who tells you do not ignore me? Do not ignore current. Okay, do not ignore this fault. Who? Why? Ideas, your insurer. Your insurer will push you to install protection against this fault. Actually, if fault current is small, it can wait until we have personnel. It's not dangerous for network, but it's dangerous for humans. In uninhabited areas, not a problem, can wait. In areas where someone can touch this wire, someone life can become a subject of electrocution. Nowadays, today, you will be pushed to disconnect this line by insurer. By the way, sometimes insurers are pushing harder because of forest fires. You can ignite forest fire, they start panic. But company will be sued for environmental damage. you need to disconnect this. And here is one tiny problem. What's the work current for this distribution line? 1,000, 2,000 ohms, yeah? And fault current, 10, 15, 20, maybe 50 ohms. We have problem with sensitivity. Fault current is very small. These isolated neutral networks were this type of network was implemented because of small fault current. Because most of the faults are Earth fault and current will be small, network can remain operational for a long time. In the days, life was cheap. Non-supplied energy was expensive. Today, life are not always cheap. We need here. Our insurer pushes us to create some kind of protection scheme to disconnect this distribution line in case of earth fault. Okay, dear insurer. What will we see? Before the fault, we had symmetrical voltage diagram. If we plant voltmeter here, U neutral, at this point U neutral was 0. At a time 0, or not 0, time B, bad time, what happens? This will be new point of neutral, because this voltage will become 0. Here, this voltmeter will show you this voltage, and ABAC will grow approximately 1.7 times, square root of 3 times. Know this. Now, more complex thing. That's what happens with voltages. You will see what? Can you measure this voltage? I'm not sure. But you can measure what? Free pole, zero sequence voltage. Free pole 0. Can you? It's a vectorial sum of line to ground voltage. You will get this one is 3.0. So you can detect fault presence by the 0 sequence voltage. Now, what about faulted line? What happens with current? And here we will go to the tricky territory. I'll assume something like this. Delta start this part, let's say 100. And here, what would you like? 20? For example, 20 kilovolts. What's your favorite distribution? Voltage for distribution network. 10, 11, 23, 20, 24. Your favorite? 20, let's say I have an earth spot here. Here is my line 1, line 2. 20, okay, here is 20. Let's try to understand what happened. To make it funny, I can add this line 3. Or maybe, okay, 2 and this one 3. And this distance is off. Fold at a distance of half. Easy. Appears to be easy. Yeah? Now, wait a second. A bar, here will be B and C. Bar A. L1 of first full place. This is 1 minus of L1. L2. L3. A. For L3. CA L2. This part CA alpha CA L1, and this capacitor is 1 minus alpha CA L1. To simplify my schematics, I can draw wire resistance and wire inductance, but because that wire is much less than 1 divided by omega C, I can ignore them. They are not playing significant role. Significant role are for line to ground capacitance. And here is my fault. Next, bus B. It will contain what? One capacitance. It's alpha L1, not alpha L1, but alpha CB L1. Next one, this one is 1 minus alpha CB L1. Next one is CB L2 to ground, and this one is CB for L3. B-phase capacitance, and here, okay, capacitance for C-phase L1, capacitance for C-phase L2, and maybe this way capacitance for C C phase L3. Here are my set of capacitance. I emitted line-to-line capacitance over there. What will we see? Here is my earth current. What will I measure? What will be current? Where my protection measuring point will be? Remember this guy? It's a cable transformer. To get zero sequence or to get fault current. Where will it be? It will get this point, this, and this. Yeah? For my transformer, I can show 1, 2, 3 measurement points. I will get vectorial sum of these currents. But what will I get? Oh, here. CL3, CL1 plus L2. Maybe, okay. L1 plus L2. Yes. Also goes this way. Note this curve. Note this point. And maybe, do I have green? BL3. This way, there will be BL3. And this one, BL1 plus BL2. We'll see him here. BL plus L1. L3. And this one means nothing. Goes away here. This one will appear AL3. Do you see what I'm saying? Here, start counting. What gets this transformer? L1, C phase, L1 plus L3. And goes, here it goes back. Yeah? Counts. What's a count of it? This way, in opposite. Result, 0. This green, goes this way. Result, 0. So what remains? L3 and this one, L3. Very complicated, isn't it? and appears something, you see what appears something wrong? Also AL3. Appears something very complex. I don't see any depends on alpha. You see any depends from alpha? You can put fault in any place here. This, maybe I showed it in orange. This point can be everywhere. And nothing changes. This schematic is quite complicated. It's hard to understand, isn't it? Believe me, it's a waste of time trying to analyze this kind of fault in phase coordinates. To get good qualitative analysis, abandon phase coordinates and start thinking in zero sequence. Conduct a zero sequence schematics. This will allow you to understand what's going on. 1 second, I will try to conduct for previous network, exact zero sequence schematics looks like this. Alpha L Y for line 1, alpha L Y line 1, all for zero sequence. Then Z of transform, sorry. I don't need, I have delta transformer. C0 alpha C0 line 1 by half. Again, alpha C0 line 1 by half. Zero sequence capacitance of your line. Here will be fault place if you need triple fault resistance. It's a place of fault. Then this capacitance will be 1 minus alpha 1 by half, 1 minus alpha L0 for the line 1, 1 minus alpha zero sequence resistance of line 1, these two capacitors are equal, and capacitance, resistance, inductance, capacitance, this all for line 2. All zero sequence elements of line 2. Not going to BTV, it's not ground. It's a common wire for zero sequence. And that's not all. Here I can show with arm method. It's zero sequence current for your relay. This voltmeter is a zero sequence current for your relay. these elements. Zero sequence resistance for line 3, zero sequence inductance for line 3, and this two is a zero sequence capacitance of line 3 divided by half. Nice schematics, yes? Here goes R of direct sequence and two resistance. They are equivalent resistance of direct sequence and equivalent resistance of negative sequence. And this somehow should go there. Current flows is of direct sequence. Here is more, it's kind of detailed schematics. Here, the ground point. Actually, this schematics is too detailed. These elements, their resistance is much smaller than equivalent of this capacitance. So, no reason to be afraid, use a simplified schematic. This one is detailed with separate capacitance on the both sides of line resistance. All this for zero sequence, so easily, believe me, the equivalent impedance of this capacitors is much higher than all this network. So this network here you can omit it, simply ignore. And from this complicated schematics, go to the simple one. Simplify. The only, believe me, the only reason to draw this full schematics is to, how to say, make an impression of your boss. It will definitely hit him out of the comfort zone and show you as a very smart guy. Simplified schematics looks like this. Bus, capacitance, zero sequence capacitance of third line, okay, I can arrow ground here. Alpha, zero sequence capacitance of line 1, triple fault resistance if needed, 1 minus alpha, zero sequence capacitance of line 1, zero sequence capacitance of line 2. Okay, this one connects here. Your power source, a direct sequence. Here is your simplified schematics. Current for your relay, zero sequence, and zero sequence voltage for your relay. This is schematics for you to analyze. Previous one for your boss. This one for you. It's simple enough and it shows everything you need to see. And what do you see? Which part determines current your protection relay will see? Here is your point where your protection stands. What will you see? This is bus where transformer connect. What is people? Is current through a railway in any depends on fault place. Alpha is determines a fault place. Is there any depends in fault current from place of fault?
We should apply baby straight out. Make statement that just need a baby sleep enjoy the day.
Without knowledge of symmetrical component, this would be a something unfeasible. But what do we see? With the help of zero sequence, I create quite simple network. And analysis of this network, what tells us? Is there any dependence in current from place of fault? How do you see it? If alpha changes, current changes. Will be any change in current. any idea. Nothing changes. Absolutely nothing. Yes, absolutely nothing. Current through relay is really in zero depends from fault place along line. Do you understand what it means? For you as protection engineer. You need to disconnect faulted line. Because insurers tell your boss, what if line remains under voltage, someone can get killed, and our company could not pay such price. And what? Can we use typical overcurrent protection here? Anything from overcurrent protection here applicable? What's your opinion? If there is no depends in current from the fault place, fault distance. What? Disaster? I can do anything. Please take me out of here. What will be solution? First, where is determination factor? Who's the driver? Who sets a current through our relay? Who determines fault current? It's absolutely madness, but undamaged part. This one changes nothing. It's a next one. Alpha changes nothing. You can put fault place anywhere, but this capacitance changes for you nothing. Yes. You in upside down world. Your current through relay is determined by non-damaged part of the network. Lines what come to your bus outside this part behind your back. That's what sets a current for you. Meaning, what typical overcurrent protection approach will not work here. We are in strange position. What will work? In such kind of network, we can only rely on what? Direction. Capacitive currents flow but that's not all. That's not all. How current flows? It flows here, yeah? But where's the voltage applied? You see what voltage is applied to the neutral. So, for you, what this means? If you have star like this, you will deal with negative voltage. Your characteristic will be built around polarizing value of minus or 0. Actually, your characteristic here is your voltage. Your characteristic in general can be something like this, where polarizing is minus or 0. Actually, read very carefully manual for your particular relay. There are relays using 0 sequence voltages and relays using minus 0 sequence voltage. Read manual. Your particular relay is operating from what? Here is the current not current, but direction characteristic. In reality, if you open something not extremely archaic, you will see something like this. Area of operation minus 0. This is operation area. And what's this part? To prevent false operation, this is pickup or minimal 0. It's your minimum 0 sequence current. Schema, you will get something like E0 greater you need to set minimal threshold for the current. Why? To prevent false operation due to network non-symmetry. Your capacitance line to ground are not equal. You will get, okay, when the phases are in line, they are close, but anyway, you see this balance because you have current capacitance A, B, B, C are much bigger than the AC. But in kind of vertical arrangement, you always see this balance in capacitance via to ground. This disbalance causes current in normal regime. To prevent false operation, you need to set minimal current. There are versions where trip from U0 start protection has also this element. It's a check for minimum of 0 sequence voltage, also to prevent false operation. Some early versions had this mandatory. I'm not sure. I heard, but I didn't check it. Some national codes require this. require start from zero sequence voltage. I'm not sure. Anyway, it's just a measure of to prevent false operation. Real, this set, this part, this R, is to prevent false operation from non-symmetry. Nice characteristic. Remember, this is characteristic for isolated neutral network. Its opening can be starting from 120 ending to 150 degrees, something like this. Not 180, it's also for safety. Do you understand how this works? It just checks direction. In case of internal fault, capacitive current flows like this. In case of external fault, capacitive current will flow this way. And this is it. You cannot use current magnitude to create selectivity. Only direction. To separate, or say segregate, faulted line from health, the only thing you can rely on is a flow, direction of current flow. Current magnitude here, worthless. But we need to be selective. Time. It isn't possible to set multiple time zones for one line. T1 delta, double delta, triple. Never set zero. Never set this protection for instant operation, or it will trip regular. Always add some delay. One second, only one zone per line, nothing more. And here, it is it. It's what you will live with. Only analyze in zero sequence. Current for them all. Actually, for this, here is upside down situation. For this one, you can set starting current higher than for this one. Because current to this protection is determined by held part of system behind protection point. So for A, it will be this line. For B, this and this line. For C, 1, 2, 3 lines. Anyway, E0, 1.1, non-balanced current max. Where will I get non-balanced current? Just measure. Real, simple measure and set high. The difference between non-balanced current and fault is quite large, you can simply measure it at roughly, you can perform calculus on base of zero sequence capacitance of your lines. You will get it with construction documents for your lines. If you don't have, check the manufacturers of cables. They all supply you with zero sequence capacitance. In reality, you can simply measure it. It's okay, it was easy, but harder. Harder thing is so-called compensated neutral. What means compensate neutral? There is one nice idea offered by one of the key researchers in Oxford, Peterson. Idea is like this. For example, okay, you have source, transformer, fault line, non-fault line. C0L1 this will be C0L2 L2 and here is schematics. This is capacitive current. What's the Peterson's idea? Idea is to add coil here. Capacitive current in opposition coil current through the coil. This adjustable coil called Peterson's coil will produce one more current, current through coil. In the place of fault, this diagram, come back, is for place of fault. What you can achieve? You can fully compensate. In case of so-called resonant neutral, coil current will be equal to current of capacitor, meaning what? If fault is 0. For oil filled cables. It's especially for oil filled cables. In case you have paper oil cable, what will happen? This cable insulation, it's oil wax, rosin, antioxidants, blah 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 made, but it will fill the damaged place. And your cable, you don't need to run, you don't need to hurry. Your cable may remain under voltage. In case of compensate neutral, current in the place of fault will be 0, and you can leave this fault. Okay, we will fix it someday. Good practice to avoid resonant over voltage is to set EL approximately 1,005 eighths. Bit overcompensate. Petersen coil. Or arc coil or arc extinguishing. If you have open overhead line, earth fault appear. In case of compensated neutral, in case you have Petersen coil, current will be 0, arc will deionize in very short time and extinguish. It's very good to, how to say, allow fault to just end. But here is one problem. BTV, I need to draw how it's done. How can we attach something to neutral when we have no neutral? It's done with auxiliary transformer. It's done by creating an artificial neutral. And this one is triple. So it's in 0 sequence, triple inductance of this coil. This is how it's done. With the help of special neutral, artificial neutral transformer. Small transformer, 25-50 kW. Artificial neutral. But where's the problem? Problem, your protection will have no current. In case of compensated neutral, here our local rules require to install Petersen coil if earth fault current is greater than 15 amps. It was required to install this Petersen coil. In all, not modern one. Modern one are more complex. Yeah. Grounded neutral. What should I do? Here problem. My relay sits here, and it will see both current from capacitance and current from the coil. It's highly possible that current from my relay will be 0. It is very tricky moment. What to do? I knew 2 answers. One answer is with charging pulse, because at the moment of fault, whole network capacity discharges to the fault place, and at this moment coil inductance is quite high. It's very tricky transient process, because coil still not magnetized. Coil, Petersen coil, will not appear with its nominal inductance. It will be smaller. But sometimes it works, but actually it's not very reliable. Pulse technique is not very reliable. In case of quite high fault resistance, it will burn through later. But in first moment, kind of branch, or what it can be, monkey, bird shit, something like this. maybe quite. Monkeys are burning well. Trees, not so. Here, local pine trees are very well withstand voltage. Piece like this holds 30 kilovolts for half an hour. We saw one would hold for half an hour. Piece like this, 30 kilovolts. If there will be a transient resistance, this capacitance discharge will be slow enough and you will risk getting nothing. Another solution is usage of higher harmonics. Using 150 Hertz component, third harmonic. In case of third harmonic, there will be no compensation. Peterson's coil resistance will be triple, and capacitance, resistance capacitance will be 1/3. So no compensation, direct. You need protection no, not all. What you will need? Triple E0, current bigger. Bandpass filter for 130 Hertz. Next one. U0 bigger. Bandpass filter 130 Hertz. Direction selector sitting on 150 Hertz. This is angular function. All this kind of protection are equipment with alert disconnection switch. You can put it to alert that it will only send the signal. Here is schematics for such relay. So, angle function here sits on third harmonic. But there should be sufficient level of third harmonic. It works very well in metal factories or where large industrial penetration, and not always in rural areas. What can be next step? Who's calling and why?
I think OCT.
Good evening. I watch all matches.
You don't support the
Oh, I've been, I got ticket in 600.
600.
Because I don't know which year cycle. Delhi, Chennai, back
In Delhi.
in Delhi. It was 600. What is square boundary, the lower boundary, this is on the squares. Please skip the next class, please guys.
Last class before he stable.
Good news and bad news. People and power components were happy with compensated neutral, but not enough. Our Scandinavian neighbors first started to cry, oh no, we can't have good protection, we can't have good protection. We need something. We need something. We need something to ensure stable, safe operation of Earth's fault protection. And idea was to equip Peterson coil with secondary winding. The secondary winding, very typical voltage, 500 volts, is loaded with active resistor. This thing closes if zero sequence voltage is greater. This resistor is not, I'm warning you, remember this. This resistor cannot withstand fault current continuous. It's only can hold full current within 5 seconds. Then it burns out. Do not operate such kind of coils without protection. This breaker will go on without protection, fault remains, and this resistance will burn. It's only can withstand fault current within 5 seconds. They are not thermal sustainable. It's a problem. How will it work? Operate from zero sequence voltage. How this thing works. Okay, for example, I had schematics of 2 lines. My bus, line 1, it's zero sequence capacitance. Here is current for my relay. for my relay? Zero sequence capacitance of the external line. Peterson coil, active resistance. I will get current through resistor and current through my coil at a place of fault. EMF capacitive current opposing current through coil and red one current of resistor. Here current through this nice resistor will always be directed towards fault place. Here is your characteristic. It will work here in Riga. This current is said to be 1 kiloampere. We have this in our city network, we have this schematic. It's called low ohm neutral. Not isolated, not compensated, but low ohm neutral. That's what we got here. I need to show EMF, where this current came from. So, in such network, you have 100% determined direction towards fault place. Good news. Your protection works very well until someone kills this resistance. Isolated and low ohm neutrals protection characteristics are not compatible. In case of isolated neutral, you need opening looking upwards. In case of low ohm resistance, you need opening look right. Isolated neutral will not operate in case of low ohm. Low ohm, very questionable. Most probable will not operate because isolated will be outside. These two characteristics are not compatible. If your neutral forming transformer is damaged or disconnected or something happened, if your resistor is not held, your protection will not work. You will be in compensated neutral with mode. It is important to periodically check all this branch of compensation for operation. It should be closed manual and for short time and current checked. Is it? You need to be sure what current through resistor emerges. It's a serious. Many I knew cases where all this was ignored and fatal mistake happened. This part it's mandatory. At least once a year should be checked. Because its damage, its fault, has no impact in normal regime. So no one will mention until disaster happens. Remember, if someone gets killed, their lawyers will skin you alive because company will be one to blame. And company will blame you. Because it's your responsibility, but protection should operate, but failed to do so. Okay, going forward. One more. Here, what I draw. Compensate neutral. With resistance, so it's low ohm neutral. This one switches if zero sequence voltage is above 1/10 of direct sequence. Something like this will be sufficient. This thing appears to be complex and a bit expensive. For small networks with small capacity of this part and small fault current, installation of complete set is too expensive. So there can be a cheaper version. In cheaper version, only resistor is installed, so-called high ohm neutral. They look like space frame with wire around. Sits on the isolating pole. IC inversion drums like this. Space frame with wire. For current, something like 50 amps, maybe less. They are for relatively small current. So-called high ohm neutral. This resistor is only needed for protection. What's good in resistor neutrals? They reduce, these resistors reduce equivalent quality of resonant contour. They protect against resonant faults and during transients. One more thing, on a voltage transformer, this open triangle winding also should be loaded with resistance to prevent resonant transients. This version is cheaper, can be used, but used only in relatively small networks. Now I can draw a problem. Problem you may face. Problem is like this. Delta transformer. Problem. generation on the opposite side. For this protection, capacitor driving force is capacitance of this part. If you have or neutral, it will work superior. But what about this protection? For protection from the powering side, from the net side, conditions are quite good, especially in case of low neutral. It will work great. But what about protection from opposite side? What capacitance it has? Only capacitance of the buses, very small. For this protection, for let's say it's cogeneration point, or worst case, customers installed solar systems with cheap inverters and can be backward transformation from low voltage side back transformed upward. In theory, owner of this source should disconnect if frequency shifts from 50 Hz. Should, but if there is a local load, no guarantee that they will not remain operational. And frequency shift is inertia. Problem maybe what this protection will fail to operate. In modern network it happens. If your company reach enough, you need to push them to install high or neutral on the generation side. If you're, if you have enough influence on your boss, client who connecting the distribution should pay for it.
As he's taking more time, I think he will.
So it's a problem of, weak end. If you have some kind of cogeneration plant or solar system or wind farm on the remote end, your protection on this line may operate quite tricky. Here operates well, but side on the generator fails to operate. To prevent it, ask for second, for full compensation, or at last high ohm neutral. Okay, one more thing. With this protection, you need to remember, let's say I have A1, A2, B1 and B2 and this is B phase, this will be phase C, so I have something like C1 and going then, sorry, this is C2. Very roughly, it's a set of two lines. And let's say I have an earth fall on my line. What happens? Why I'm drawing this? Diagram. At the moment of fault, neutral point moves upwards. And B and C phase voltages grow up square root from 3 times. Actually, in moment of transient, over voltage, remember this digit, will be 2.6 times voltage in short time, in the point of transient, 2.6. And what may happen? In your network somewhere insulation fails and you get second fault, for example here. It's a problem of earth fault in urban networks. What do we see here? In reality, it's a AB line-to-line fault with quite huge current. 6, 7, 8,000 amps, maybe more. But what will see your protection? Your protection, watch here, here and here. For your protection, only this current will be visible for protection number 1, and for protection number 2, only this one. Double earth fault for your protections will appear as 2 single line faults. Zero sequence voltage will disappear, but it will not save you. Problem, but in normal earth fault you have quite small currents, so you need something quite sensitive on this, actually on these terminals. Do I have terminals? Here, at this terminal should be something quite sensitive. But in the case of double earth, you will see huge current. Not any current relay and not any current sensors are good for earth fault protection. Be careful. Only special designed old style relays had special transformers, separatable transformers. Modern has a special current limiters. There is necessity to, on the one side, be very sensitive, but on the other side, withstand huge currents. Double earth can be top value 10 kiloohms, something like this. Really 5, 6, 8 kiloohms, nothing unseen. So be careful, your input is for earth fault or general. More. What can be more? Oh, I used all time. What's more? Yeah. Keep an eye on NATO regimes. Oops. Attendance chart, where are you? Come here. Come here, my small attendance chart. Oh, 1, 2, 3. 1, 2, 3. Yes. Tricky thing. What painful. Distribution networks rarely have enough funds to hire good engineers and management. These rulers are often do not understand how complex are these networks. Okay, what shall we do?